My name is Franz Degen. I'm the CEO of Dewesoft Austria. Right now I want to show you the latest technology, the latest innovation in data acquisition units. Data acquisition units are done for 30, 40 years. I do it and sell it for 30 years. But this is unique. Why? Look at this. We have several input channels and you connect any sensor. You don't even know what kind of sensitivity. The dual core technology running two ranges will care about that. You just connect, you measure. You have small signal inputs, you have high signal inputs, microvolts or high voltage, vibration, counter, whatever. That's it, and we will show you how you're going to use that in a minute. Dual core AD converter, what does that mean? First, let's talk about the dual core ADC advantage. Here we definitely need the advantage that the problem most customers have if they do not know what is the signal they're gonna acquire. So if they say, okay, I hit a hammer, you don't know how many G level you have. So the best, if you don't know, is either you have a small signal or big signal, you just measure in two ranges simultaneously and take the best data from either the big or the small signal. To show that as a demo, we go to Dewesoft and then show this as an example. How to demonstrate it is, now I have connected two ICP sensors on channel 1 and channel 2, and I take now the channel 2, the one sensor is just fixed on the table, and show you now with the measure mode the very small little signal. So here we see as a recorder signal, and you can see already my voice is recorded. Here on top we can see the dynamic range, and when you look at the small detail, how much we really record, then on the scaling here you could see maybe this is maybe 10 millivolts plus minus. If I go to full range, you see this is 10,000 millivolt full range. So how about now? We don't see anything, but if I just make auto scale, you can see the small tiny signal coming from this sensor. I store the data now. If I store the data, then, so I record my voice now. If I make a real hit, of course you see this is a huge signal, but I still can record my small voice behind it. Let's analyze that. I stop, I press analyze and look at the data. You see only the big hits here, this is this signal, but how about in this area? No signal, for sure there is the signal, you see this is my voice behind it. Here now we show the huge dynamic range showing with this sensor. Going back to acquisition, what does it mean, huge dynamic range? The dynamic range is measured in dB, in decibel. So to show the full dynamic range of the system, I could either use, and as you can see now, the lamp goes from green to off. So back on, you see green, that means the current to the sensor is okay, that means the sensor is okay. If I now short circuit the input, you can see the signal goes to red, so it's now short circuit, and now in this range you see the you see now the average of the FFT down to 130 something dB. This is now including the ICP current. If you want to see the whole dynamic range of this amplifier, what we do is you go back to channel setup, change this from ICP to voltage, and go back to the measure mode, and then you will see the full dynamic range. Now you see the scaling is minus 140, you can't even see that anymore. I go to minus 170, press once the reset, and then we can see up to 160 dB dynamic range. This is what we see here in our most new dual range, dual core application. So if this does not satisfy the customer, then maybe you are at the wrong customer. If the customer understands that, he will buy immediately. This is the first section.
Thank you very much, Franz. He did a perfect demonstration of the high dynamic range of the new Sirius instrument.